Hello, welcome to another tutorial. In this one we're gonna create something like this. So here I'm using a fire and smoke simulation, and I use geometry nodes and the new volume grids feature in Blender 5 to create sort of a heat tracer. So what you see here, those dots that are left over at the end of the animation, those are marker particles, and they mark the voxel locations where we had the most heat. Maybe you've seen this animation on my Instagram, and if you're not already following me on Instagram, then why don't you? And at the end of this tutorial, I will show you that file and how I put all of this together and what it actually does. I make these tutorials here for free for you, and I hope you can learn something new today. And if you do, please don't forget to like the video and subscribe to the channel. It really helps me out. If you also want to support me over on Patreon for just a few bucks per month, the link is down in the description, and it's easy to remember. It's patreon.com/chrisp. And the finished blend file of this tutorial, just like with all the other tutorials, can be downloaded over at Patreon. Enough said, let's jump into Blender. Okay, I am in Blender 5, which is still, where is it? Splash screen, 5 alpha. Yeah, so it's still in alpha. But we need Blender 5 for the new volume grid feature. The first video on volume grids is just a few days old now here on the channel. I will link it up there somewhere, and of course down in the description. Maybe you want to check that out first. So you've seen this website before. I've shown that in the previous tutorial. Here you can download free VDB volume files. And I downloaded this one here, the Gasoline Explosion, 700 megabytes, 130 frames thereabout. So I will not include this in the download on Patreon. You will have to get that for yourself. But once you downloaded that, you can go to Blender. You can open the folder where you downloaded the files. So here are the 131 VDB files. I just select all of them and drag and drop them into Blender. Now it looks like there's nothing there, but if I hit spacebar, you can see it's just unbelievably huge. Okay, so this gas explosion that they simulated here, it has a lot of detail and it's really, really nice. But yeah, it's pretty big. So I let it play to the end. What was it? 131, I guess. Let's let it play a little, because now we can see that this down here is where the explosion started, and I want to bring that up to my origin point here. Something like that, and then look at it from the right. Again, a G, move it. So this is the explosion. As you can see, if I scroll back, we get clipping, because this is, like I said, it's huge. We can hit N and we can go to view, and then we can increase the clip end to more so that we're not clipping when we scroll back. Now let's see if we can actually see anything in rendered view. So let me split the screen, switch this to rendered. Okay, this looks like that. Okay. I'm gonna go in here. Oh, first of all, I want to switch over to cycles, and of course I want to switch to GPU 512, no denoising. Yeah, full frame, 30 frames per second is what I want. And what else do I want? Oh, I want the world to be black, so I switch that off. Of course, now we can't see anything, so we do have our default light in here. That's way down there. Okay, cool. So in front view, let me just bring it up here and turn this into a sunlight. And then we can see the smoke. Already looking pretty cool. Now let's go over to shading, or I'm just gonna bring up a shading tab down here. Switch this to the shader editor, and then play with this material. It doesn't have a material, so let's give it one. By default, since this is a volumetric object, it automatically gets a principled volume, and it uses the density that's stored in here. By the way, if we go to this tab here, we can see we have density, flames, and temperature. We do not have velocity in these files that we downloaded. But that doesn't matter, because we want density, we want flames, and we're going to use the temperature. Down here you can see the default principled volume already uses the density attribute for the smoke. And down here it uses the temperature. except that we can't really see any like flames or anything. We have to turn up the black body intensity, and that should, yeah, now it gets, we get some red. The temperature is 1000 Kelvin. Let's turn that up to, I don't know, 5000 Kelvin. Ooh, that's a bit much. Okay, so this would be that gas explosion now rendered in cycles inside of Blender. Of course, my camera, where's my camera? It's also way down there. Okay, let's bring it up here. Alt R to reset rotation, and I'm just gonna bring that in. I have to rotate 90 negative. And if I look through the camera here, I'm pretty sure that this camera also clips. Oh yeah, clips at 100 meters. So let's turn that up. Okay, now it's time to jump into the geometry nodes to get the heat tracer feature. So this is just something I came up with. I thought, what can I do with this information now that we have the volume grids in Blender 5 in geometry nodes? So I'm jumping over to the geometry nodes workspace. This is our huge explosion. And with that selected, I'm going to create a new geometry nodes node tree. Now, just like I said in the last video, we can access these volume grids, density, flames, and temperature inside of the VDB file by simply getting a named grid. So get named grid. And then we have to type in what we want. I'm thinking we have a bunch of voxels and each voxel has a temperature. And I want to spawn a particle and just stick it there in 3D space and leave it there, where the temperature is above a certain threshold. So I need to get the temperature grid, Temperatur, like that. Okay, it's a float value, yes. So here we can then sample the grid. That gives us a float value. And now here we have the actual temperature. And now I want to create those little dots for tracing where the hot voxels are or were. So I'm gonna have to get another grid. I'm gonna use the flames grid. So it's flames, right? And inside of the flames grid, I can now distribute points in grid, just like that. Then I'm gonna pick a density. So the higher the value, the more points I get. This is a huge simulation, so I'm gonna get a lot of points. So I probably set this down to something like 0.1, and I can play with this a little later. Also, when I switch this over to cycles, to rendered view, cycles not only renders the volume here, but if we look at the points, well, those are tiny, tiny points. I can't even tell if you can see them. So we're gonna have to set a point radius. So we can increase the point a little, the point size. Let's set it to 0.2. Cycles can actually render points, and it creates tiny little spheres. So with the radius here, I could set the radius, and it just creates perfect spheres. We also want to give each point a temperature, right? Each point has to know its temperature. How do we do that? Well, we can store a named attribute onto each point. We call it temp, a float value on each point, and the temperature we want to store is, of course, this one. Okay, so now each point knows its temperature. How can we visualize this? Well, we're gonna have to create a material. So let's create a material. Let's call it M for material. Go over to shading. Also switch this over to... Switch this off, okay. Here we have the principled volume. Oh, that would be our volume. I'm gonna create a new material. Call that M. And then on M, I don't want a volume. I want a surface, maybe an emission, a shader. And for the color, we could use our temperature. Okay, so let's set the strength way up. And then we use an attribute We used the factor and we called it temp, I guess. Let's see. We're setting it on to the points. So we're on the geometry and it's called temp. Yes. Shading, we're using it from the geometry. It's called temp. Maybe we can already tell the difference, but we can always drop in a color ramp. Convert a color ramp. And then we go from blue or aqua or whatever to like orange, HSV, clockwise like this. And we should see some colors here. Ah, wait a second. Geometry nodes. Every time. So these are the little dots. I have to set material. And I have to use M. Yep. And now we have colors. That's a lot of points. That's not exactly what I want. Well, it looks cool. But instead, I actually want to use these points now and delete all of the points that are not hot. Okay? And then I keep those, add them to my simulation. And on the next frame, again, I distribute a bunch of points, delete all the ones that are not hot, and add those to my simulation. So, keyword being a simulation. Whenever you want to do something over time through the course of your timeline, you can use this simulation zone. Everything you plug in the front here is only for the first frame, and I'm not plugging anything in there. And in here, I'm just gonna join geometry. We start off with an empty mesh, if you will, or an empty point cloud. And on each frame, we add the points where the temperature is high. So let's do E less than, because that's what we want to delete. Let's just start with 1. It's less than 1, and we delete those. So we have to back here, right? So we delete the geometry back here, this selection. Okay. This is the temperature we want to store. And if it's less than, how can I put this so that the noodles are not all over the place? Okay, so here we're creating points. We're setting the radius, storing the named attribute, and setting the material for the dots. And here we go. Okay, if the temperature is less than 1, we delete the points. And those are the ones that we add to our collection of points. And this is actually what we want to see. So what does that look like? And by the way, we could bring that in here, because those are the points now. Okay, spacebar. Yep. Okay, so we're adding points. And you can see already here on frame 60, I think we're basically done. Those are all the points with a certain heat. Now, 1 as the threshold seems to be quite a lot. So let's try 2 and go back, spacebar. Okay, there's nothing appearing. So I guess the maximum temperature is somewhere between 1 and 2 in this simulation VDB. Let's try 1.3, spacebar. And I think this is good looking. Let's just look at this real quick. Yeah, so those would be our tracer dots. I think I want more dots, so I'm just gonna distribute more points. Oh, what can I do? 0.5. Let's see. Is that too much? No, this looks good. Okay. Yeah, this looks nice. So this now traces the very hot areas of this explosion, which I think is just so cool that we can do. I mean, this is not difficult to do. And we can do this kind of stuff now inside of geometry nodes based on a really detailed, very nice VDB file set that we got from some explosion. Cool. Now, how can we add the smoke back on top of this so that it looks a little cooler? Well, the smoke is just this. So all we need to do is, let's just put in a join geometry, plug that in here, and put the smoke back on top. And then we get this. So Awesome. Yeah, so this is what it looks like. All right, now let me show you what I did here. This is that file. It is actually very similar. It just has a lot more nodes for other effects and stuff, but it's really the same thing. I used my own smoke simulation. Actually, this is the smoke simulation that I created in the last tutorial. So again, if you haven't seen that yet, maybe you want to check it out. So based on this smoke simulation, again, I have a geometry nodes in here. And the smoke simulation is coming in over here. This is the fluid data. Now, if we just look at that, if I select that, well, that's just the smoke sim, okay? Now, the origin point of the smoke sim is always like off to one side. So I used a transform geometry to move it to the center. And then what I did down here was I sampled the density grid and I created a new density grid. Well, in this case, it's actually a volume cube where I set the density based on what I'm sampling here. So if I take this out, you can see this is the same simulation, same smoke simulation that I created in Blender. And now I'm reading it from the VDB cache. Okay, so I'm reading it, I'm sampling it, and I'm setting the density onto a new volume cube, which just gives me, well, the same thing basically. So not much different than looking at this. This is the original, and this is now like a volume cube created from sampling the volume grid. And why am I doing this? Because now I can manipulate the volume in here. For example, I can plug this in here. Now I'm sampling my cache, but I'm looking at it like through a different coordinate system, if you will. So what am I doing? I'm adding noise to this sample position vector here, okay? And I'm also rotating it. So if I hit spacebar now, you might be able to tell the difference. So we have a little bit of noise, which would be turbulence. Yeah, so I'm adding noise, but only in the higher regions up here. So down here, there's not much noise, but up here we get a little bit more noise or turbulence. And then also I rotate the vector again based on the height so that we get sort of like a spiral, like a twister. What do you call it? What's the force field called? Vortex, yeah. Okay, so I'm rotating the coordinate system, and that's what this sampling does. And why did I do this? First, I wanted to play with it, and second, I wanted to see if I can use that, do stuff like this inside of geometry nodes, and then base other animations on that. And it's actually really simple because here I'm creating a new coordinate system for the sample grid node. And I can use this position that I calculate down here up here as well to, for example, sample the velocity. And yeah, so I can base the animation, which gives me those sparks based on the modified volume. So I don't even have to recalculate my simulation. I just use the simulation. I add a little bit of a vortex and I add a little bit of turbulence all inside of geometry nodes. And then based on that, on the modified volume, I then create my animation. In this case, I'm creating little sparks that are falling down. They're slowing down. Okay, so this is hard to see here because it's so slow. But maybe what if we just look at this? We should just see the points. That's much faster than with the smoke. Okay, so you can see here, these sparks, they're falling down. They're like slowing down in midair. The ones that hit the floor actually crawl along the floor. So what I did here was, I said, I'm sampling the velocity. Okay, the velocity is a vector. And I'm distributing points. And again, in this simulation zone back here, I'm adding points to an empty start. And then I just keep adding points to that. But only the points of voxels that are actually moving downwards. So descending voxels. Okay? So down here, I'm picking the velocity vector. I take the c, and if that is less than negative 0.4, so if it has some speed going downwards, I'm deleting all of the points that are not descending, which gives me the voxels on the basically on the outside of the simulation where the smoke cools down and then starts falling down. So I'm taking those voxels on the outside and I distribute points there and I add those points to my simulation. Also, I'm giving them a random point radius. I'm also storing the vector, the velocity vector, onto each point, and I'm also storing an age starting at 0 to each point. So very similar to a particle simulation, each point now has an age. Okay, we're joining this so we're just increasing the amount of points all the time. And so that we're not going into the hundreds of thousands or millions of points, because that would just crash and it also wouldn't look very nice. Down here, I use the age. Where am I using the age? Here, I'm using the age. I add 1 on each frame. Okay, and if it's greater than a set number coming from the group input, so on the modifier here, so all of my pixels here, all of my particles will not be older than 30 frames, then I delete the particles. I also calculate an age float factor between 0 and 1, also based on these 30 frames for the age. So I have a stored named attribute called age_f, which is between 0 and 1, and I can use that in the shader. Okay. So yeah, so we keep storing the age after we add 1. We keep storing the age factor, which is just divided by this 30. And then, of course, we also have the v, which is the vector. And we're manipulating this vector. So we're reading it, we're scaling it, which slows the particles down. You can see they stop like in the air. Sort of like embers maybe, I don't know. So this is just to slow down the particles. So we read v, scale it, and store it again. And down here, what is this? Oh yeah, this is the separate XYZ and then maximum on the C, which is this floor, if you will. So the particles have a certain vector and they're, and they're traveling in a direction. But if they hit the floor, then they just keep traveling X and Y. But I'm setting the C to the maximum of C and 0, which means they will never go through 0, which sort of means that they kind of slide along the top here of my base plate. Okay, so this is a pretty awesome looking particle simulation, and it's all based on a smoke simulation. So that once again, this is what we get. Yeah, so I don't know, maybe this could be used for like rain simulations or something. I have no idea. I'm just playing around. This is that setup. All right, once again, all the links to all of the things are down below. Like and subscribe. Thanks for watching. See ya.